This is Dr. Mohan Lakshmi, Professor and Head Department of ECE from Rohini College of Engineering and Technology, Kanyakumari District. So in this lecture, we'll see about the frequency response of an BJT amplifier. So frequency response operation of a BJT amplifier. So from the figure, we have the various capacitors mentioned, CS, CC and CE. So this will determine the low frequency response. So the CS is normally connected between the applied source and the active device, and the total resistance is now RS plus RI. So the cutoff frequency is established as FLS divided by half of M into RS plus RI into CS. So this is with the capacitors. So whatever capacitors I mentioned over there. So with respect to the collector CS, with respect to the emitter CE, and with respect to the source, which is your CS. So this will affect the low frequency response. So all the capacitors connected will affect the low frequency response. Okay. So what would be the effect of CS on the low frequency response? So at the mid or high frequency, the reactance of the capacitor will be small to permit short circuit approximation for the element. So the voltage VI, that is at the system, you can see there is a voltage VI, which can be related to the source voltage Vs by, it is given as RI, that is Vs divided by Ri plus Rs. So the value of the input resistance, that is your Ri, also can be determined. Okay, so this is a localized AC equivalent for a CS. Okay, so I have this VI where the current flow with the R1 parallel to R2. So this is actually the HIE, which can be given as beta RE. This is a AC equivalent for the capacitor which is connected at the source. Okay, so the voltage VI is applied to the input of the active device, which can be calculated using the voltage divider rule. Okay, since the coupling capacitor is normally connected between the output of the active device and the applied load, the RC configuration that determines the low cutoff frequency is due to the coupling capacitor CC. Okay, so the total series resistance is now, that is R0 plus RL, and the cutoff frequency is determined to be the given expressions. Okay, so which involves a R0, RL as well as the coupling capacitor. So the resulting value of R0 will be equal to the collector resistance, which is in parallel with the R0. So to determine the very same thing for the common CE, right? So the expression is given to be which is given below. Okay, so the value of RE is determined by RE is equal to RE which is parallel with RS dash by beta plus RE, where it is given by the above expression. So at the midband frequency level, the short circuit equivalence for the capacitors can be inserted. So the highest to low frequency cutoff determined by CS, CC or CE. If there are two or more high cutoff frequencies, the effect will be to raise the lower cutoff frequency and reduce the resulting bandwidth of the system. Okay, so this please kindly make a note that the effect of CE on the gain is given by AV is equal to minus RC, which is with your RE plus RE, and the maximum gain will be available when RE is 0 ohms. That is, we don't have any RE, then you can get a maximum gain. At low frequency with bypass capacitor CE in open circuit, as the frequency increases, the reactance of the capacitor will decrease, so which will reduce the parallel impedance of RE and CE until RE is short circuited or shorted out by CE. Thank you.